90% yield. And you know, you can, if I tell you you're supposed to make 100 grams and you only make 95 grams, what was your percent yield? That one's easy. That's why I gave it to you. So let's say the math says you should be able to make 100 grams of something. You measure your product, you only made 95 grams. Okay, so in that example, it's 95%. And you know that you're taking what you actually got, what you measured, what you carefully scraped out of your dish, and you're getting a mass, and you're comparing that to what mathematically you projected you would be able to get, what you should have gotten, your theoretical yield. So the easiest kind of problem for these things, we'll rank these in order of easiest to hardest. Easiest kind of problems. What I just did. I tell you what you actually got, and I tell you what you should have gotten. You figure it out. You could do that blindfolded in your sleep with no coffee. I swear to you, you could. Very easy. We can step that up a notch. We make it a little bit harder if I give you the amount of one reactant and I give you an actual yield. So in that case, you have to figure out the theoretical yield. But I'm only giving you the mass of one reactant, so we know that that reactant's all going to be used up. We're not comparing reactants. We're not doing anything like that. And we did some examples of this the other day. What we haven't done yet is the hardest kind of percent yield problem. You knew that this was coming. I wasn't recording. So in this third type, before you can even figure out the theoretical yield to compare it to the actual, you have to figure out which reactant is limiting, because that limiting yield is going to control how much product you can make. So we'll put a star on that. So yeah, in that third type, you have to figure out the limiting reactant before you can compute your theoretical yield. So let's go ahead and do one like that. So we're doing iron 3 phosphate. Can you write a reaction for iron 3 phosphate and sodium sulfate? So iron 3 can't do it. Phosphate and sodium sulfate. And we're doing a double replacement reaction, so go ahead and predict products. You've got this, now you have to balance. Okay, we'll record here. So if we've got a balanced chemical reaction, if we do this reaction with 25 grams of iron 3 phosphate and 32 grams of sodium sulfate. Well, let me write this down. So given 25 grams of iron 3 phosphate, 32 grams of sodium sulfate, we produce 18.5 grams of iron 3 sulfate. What's your percent yield? Oh boy. Where do we start? Well, we start by figuring out which one is our limiting reactant. That's the first place we go. So I'm going to move some stuff up. So if we're going to do this, my first step here would be to figure out all my molar masses. So I need to figure out my molar mass for FePO4, sodium sulfate, and the iron sulfate. So I'm going to do that. Okay, so we have our molar masses done as a first step. They're kind of set off to the side. This is the tedious accounting, bookkeeping kind of part of it, where we just have to get that stuff done. Hey, I reversed 2 numbers. That mass for iron 3 sulfate is wrong. Let's try that. 399.91. Seem more reasonable? Okay. It pays to have 2 people doing the same math sometimes. Okay. So, where do we start from here? Start a factor label, and we can pick either one of our reactants. So I'm just out of force of habit going to start with the first one listed, which is our iron 3 phosphate. Okay, so we have a factor label set up here. Did I miscopy something again? Sodium sulfate, I might have screwed that one up too. Let's check it. Okay, I reversed numbers also in this mass, so that mass is incorrect. I'm having a great day. Okay, so I fixed my math errors. Jeez Louise. Okay, I'm having one of those days where I can't do simple arithmetic with a calculator. Terrifying. Okay, so now we do have the right numbers, right? Please triple check me. What do we get for grams of sodium sulfate? Anybody got an answer a lot like this? 35.319 grams of sodium sulfate. Okay, so which one's the limiting? Yeah. We could react 35, etc. grams of sodium sulfate, but we only had 32 grams of sodium sulfate. Now, do we have to go into finding out how much of the excess remains? Nope. We're done with this one. We don't have to go there. We just needed to know which one was the limiting. So, because we don't care. We're just asking what the percent yield is. Now, we do have to do another factor label. What do we have to calculate? We have to come up with a theoretical yield of iron 3 sulfate. And we have to start that calculation with our limiting reactant because that's going to control how much product we can make. So I'm going to shrink a bunch of stuff. Okay, and just because it's still helpful a lot of times if we do the sentence for it, let me write it and then I'll read it. Okay, so 25 grams of iron 3 phosphate could react 35 grams of sodium sulfate, but we only have 32 grams of sodium sulfate, so we run out of sodium sulfate. Okay, does that make it easier, having the sentence? I think the sentence is really helpful. That makes it the limiting. And since it's the limiting, that's what's going to control how much of our product we can make. So now we have to do another factor label that starts with our limiting and goes to the product that we're interested in mass. Okay, so we have a messy factor label, but a factor label nonetheless, that's going to get us from grams of sodium sulfate over to grams of iron 3 sulfate. And what's our raw number? Whew. Okay, so we get a raw answer of a little over 30 grams of the iron 3 sulfate. What is that number? Okay, that's how much iron 3 sulfate you should be able to make with the amount of sodium sulfate you were given. If it's the amount you should be able to make, it's your what? Theoretical yield. So now, after all that work, we can go back and do the actual versus the theoretical. So I'm going to shrink some stuff. Okay, there's our actual and our theoretical. Oops. What do you get? Yeah, 62% yield with sig figs. Raw answer was 61.605, etc. 62% yield, that's really cruddy. Like you had a major problem somewhere in your lab procedure if you're getting a 62% yield. That's bad. Do you see how to do these more complicated ones? The nice thing about them is that it actually helps you refresh and practice the percent yield or the limiting and excess skills while you do them. I'm going to give you a couple practice problems and let you work while I float around because I think, yeah, you probably want some practice on these. Okay, you have your practice. The key for the practice will be up by the end of the day. You will have an assignment with a tutorial video to watch at home for crystalline solids. You can do that anytime during the day. That will be posted shortly. And tomorrow when you walk in, there will be a FIP quiz on percent yield with all three definitely the first two types of problems and some conceptual on the third type of problem. Then we'll talk a little bit more about crystalline solids and the assignment for the museum. Have a good day, folks.